Okay, hi everybody. This is lesson 1.4, Statistical Analysis in Psychology. The objective today is to explain why statistics are important to psychology, and we're going to take a look at the mean, median, and mode, and probably do one of these activities together as a group when we meet in class. I promise I will try to make this as simplified as possible, and we only have to talk about stats today. So a frequency distribution is just a way to summarize the data. So we may take a look at our mean and median and mode, and then we may want to take another look at a way to summarize our data, and that's where we would use frequency distribution. And this is an example of frequency distribution. So what I would do then is I would take my data set, right? So I would take all of my numbers listed out, and then it would tell me exactly how many people fall into each category. So in this case, I have I've got two ones, two threes, four fives, one five, and two sixes. This could be super helpful as another way to look at my data to give me a better picture of exactly how many people fit into each category. So if I'm looking at income distribution, this might be more useful because then I can tell exactly how many people fall into each income bracket rather than looking at something like the mean, which may not be very representative. So another way to take a look at that data is to take a look at the range. And the range is going to be the difference between your high and low score. So if I took a look back at that income, then I might want to look at the range of that income, and it might prove to me that there's a huge difference between the highest and the lowest, and that neighborhood may not be as equitable as I thought. Another way to look at our data is by using what we call standard deviation. The standard deviation, what that means is it's a computed measure of how much scores vary around the mean score. Well, what exactly does that mean? Okay, it helps us determine if the scores are packed together or spread out. This is super helpful when you're looking at, again, that income, right? In that case, those scores or those income ranges were super spread out. So you're going to see a neighborhood or a community very much like the city of Alexandria, where you have people on both ends of the wealth spectrum, versus maybe other areas where people are a little bit closer together as far as their income is concerned. Another example is if you took a look at Akron, Ohio, right? Akron, Ohio, the range is going to, of income, the income range is going to be very huge. Why is the income range in Akron, Ohio going to be huge? Well, LeBron James lives there. LeBron James has a very large income. He also has a very large home. Most people in Akron, Ohio don't make that much money and don't have that big of a home. So you're going to see a very large standard deviation there because it's going to be super spread out. Versus if you drove to the next town over, which has a very similar setup but doesn't have LeBron James, you're probably going to see a much smaller standard deviation because it's going to show us that the scores are more packed together. Now, here is how you calculate standard deviation. Standard deviation equals the square root of the sum of the deviations squared over the number of scores. You are not going to have to calculate this out, but it is good to have an understanding of how we calculate this score just to make you more aware. So once we calculate the standard deviation, this is what it's going to look like. We call this the normal bell curve. The normal bell curves means that you have the same amount on both sides of your middle score, right? Which in this case is 100. This shows us that 50% of individuals are going to fall below and 50% of individuals are going to fall above. You want this to, or your data to look like this when you're conducting research. Now, what you are going to have to know about the normal bell curve is you are going to have to know that 68% of the population fall within one standard deviation of the mean. This means one positive standard deviation over here, one negative standard deviation over here. If I were to ask you how many people fall within one positive standard deviation of the mean, that number is going to be 34. If I ask you how many people fall within one negative standard deviation of the mean, that number is also going to be 34. 34 plus 34 equals 68. So therefore, we have 68% of people will fall within one standard deviation of the mean. I'm going to erase this for a second. Now, if I were to ask you the second number that you're going to need to know, is this 95? If I were to ask you how many individuals fall within two standard deviations of the mean, that is going to be 95. Because if I were to ask you how many individuals were to fall within two positive standard deviations of the mean, we're going to go back to our 34 because that's 1. And then we're going to add on 13.5. So if we do that, we have 7 and we have 4. Oops. 47.5. Sorry, that doesn't look very good. Let's erase that for a second. My fault, team. All right, 47.5% fall within one standard deviation or two standard deviations of the mean. If I were to ask you how many people fell within two negative standard deviations of the mean, that is going to be 47.5. Guess what 47.5 plus 47.5 is 95%. So that's how we get to the 95. These are the numbers that you are going to have to remember. So you are going to need to know this 34, 34, 13, 13, or 95 and 68, whichever is easiest for you to remember, but you are going to need to know those. Well, what happens if we don't have a perfect bell curve? Then you're either going to have what's known as a negative skew or a positive skew. Negative skew means that you have an outlier negative score that skews your graph. So instead of having the normal bell curve that we would see, this one really negative score is going to skew your bell curve and make it look a little funny. A positive is going to be the exact opposite, right? You have one outlier positive score, and that is going to cause you to have a positive skew. So again, instead of having your normal bell curve, it's going to skew or move out to accommodate that one very positive score. So what do I do after I have all this data? Well, I hope that my data proves that my results are what we call statistically significant. And what that means is that is just telling us how, oops, let's do, there we go, how likely it is that the result occurred by chance. So what we want to be able to see is that if we conduct the experiment again or the study again, we would get the same results or we would get similar results. So we don't want our data to show that this could have happened by chance, right? We are hoping that the data is going to show that the independent variable caused the dependent variable and that we would be able to repeat this experiment again and get very similar results. And that would prove to us that our study is statistically significant.
Now, I just gave you a lot of information about statistics. We are going to do a whole lesson on this in class as well as this. This is just to give you some base knowledge so that when we do this in class, you already have some basic understanding of what statistics is. And we can spend class time making a deep dive into what does this really look like and what exactly do you need to be aware of for psychology and basic psychology understanding.